protons, neutrons, and electrons, and we talked ions. I don't think I wrote it down on the board. Does anybody remember a two-word definition of an ion? Charles, were you volunteering there or stretching?
Sorry, what's the question?
You were stretching, but could you tell me what a charge, what you about gave it away? What's an ion? I about said it.
It's a charge particle.
Charged particle, good. Okay, so an ion is a charged particle, as opposed to having a neutral atom or clump of atoms here called polyatomic atoms. Okay, now to be more specific, we have anions and we have cations. Now notice the pronunciation here. In English, usually a T-I-O-N is like a shun sound, vacation, that kind of thing. Cations, because you want to emphasize the ions. So anions, cations. Anybody know or remember from another class? Anions are carrying what kind of a charge?
Positive.
Negative. So negative ions, and these are positive ions. Okay, so ion is the general term, but if I want to be more specific, I can say this is a cation or this is an anion, and notice there are no dog ions here. So add, how are you going to remember that? If you know, we got positive and we got negative. How are you going to remember it? Cations. Cats are something positive, right? So, positive ions. Now, how do we make ions? Remember when we were talking about protons, neutrons, and electrons? Got a proton. What's the charge of a proton? Positive. What's the charge of an electron? Negative. But, if something becomes charged, what's happened to it? Do you remember that big generalization? We're always playing with what, Nina? Electrons. Electrons. And so, and two we played with before. Okay, I've got this. And then another one I think we took a look at was this. So how do we speak? This is an ion of fluorine. It's not a fluorine atom anymore. It's a fluoride. Endings, IDE, here for negative ions, but that's going to be later this semester. So this is the fluoride ion. Okay, so they talk about you need fluoride for your teeth. You don't need fluorine, you need fluoride. Yeah, yeah.
So if the element has a negative charge, it ends in IDE?
Yeah. And then sodium, I could say it's an ion, this is an ion, but if I want to be more specific, instead of just saying ion, I could point at this and it's an ion, but Antonio, it's also a what? What's a negative ion called?
Anion.
Anion. And this one is called, while you're on a roll there? Cation. Okay. Now, how do we make them and how can we predict them? Okay, you saw before how we made them, and Nina, I think, said we gain or lose electrons. Brittany?
An anion adds electrons and cation is taking away electrons.
Precisely, precisely. Everybody catch that? If you've made an anion, you have gained electrons. If you make a cation, you have lost electrons. So let's just review something from chapter 1. If you are -1, what's happened to you? Gain 1 electron. If you're -2, what's happened to you? Gain 2. If you're -3, gain 3. Okay, if you're +1, what's happened to you? Lost 1. If you're, let's see, +2, lost 2. We're +3, lost 3. Usually, +3 is as high as we go, -3 is as low as we go, because changing around more than 3 electrons just costs you so much, it usually doesn't happen. Okay, now, here comes new part. How can we predict here what charges are going to form? I mentioned a couple of broad generalizations. And I said, first of all, if something happens, a chemical reaction, we're gaining electrons, we're losing electrons, we're playing with electrons. And Nina just said that for us. The other major idea in chemistry, there's always a drive towards stability. Okay, what's stability? Having a fine number of electrons. Okay, who has been found to have a fine number of electrons? These guys right here. Because we know from experience they are super stable. These are called this 8A family. Remember, the verticals are the families. And if you're in the same column, you're in the same family, you've got a lot of similar properties. These guys are super stable. Super stable. They have a fine number of electrons. Everybody else, or most other things, would like to get to their number of electrons. Okay, now remember, which is this? Is this the atomic number or the atomic mass? The atomic number. And this tells us how many what in the nucleus we have? Protons. But if you're neutral, it also tells us how many electrons. So helium has 2 electrons. That must be super good. Okay, neon has 10. Argon has 18. Krypton, Superman's planet, has 36, and so forth. Okay, team, here's something super important that'll make your lives easier throughout this semester and next. I got a fluorine sitting here. He's not real happy. He'd like to be more stable. When he's neutral, how many electrons does he have? 9. How many would he like to have? 10. So what's he got to do? Gain 1. So fluorine wants to gain 1 electron, and if he gains 1 electron, he becomes what? -1. Nina?
I'm confused. You said that they're all shooting to have 10?
No, they're all shooting.
Well, what you want to do is get to the closest guy possible by shifting the fewest number of electrons. It's like 2 is a good number, and if you're close to being 2, it's going to happen and get you there. If you're close to being 10, it's going to happen and you'll get there. If you're close to 18, it's going to happen and you get there.
So they're trying to have an even number?
They're trying to be like a noble gas. Okay?
I think I'm mixing it up with the octet rule.
Okay, forget the octet rule. Put it out of your mind. Just listen, keep an open mind. You know, if the first few of these we do, if you're thinking, holy whatever, that I don't understand this, keep an open mind, and I can almost guarantee everybody's going to have the aha phenomenon. Okay? All right, up here. Brittany and Nina, up here for a few minutes. Just listen, and then she can help you to break time. Okay, fluorine normally has 9. What does a fluorine want to do? Gain 1. And then it'll have 10, and it's like neon. The fancy word for that is that it's isoelectronic with neon. Iso means the same, electronic, same number of electrons as neon. That's good, because there's a drive toward stability. Okay. Oxygen would like to do what? Gain or lose electrons? Gain. How many? 2. Because if it could gain 2, it goes from having 8 to having 10. Woo, that's good. And if it gains 2, what charge does it take on? -2. Everybody holding up? Okay, don't tune out. Nitrogen, what do you suppose it wants to do? Gain or lose? Gain. How many? 3. If it gains 3, what charge does it take on? -3, and it becomes isoelectronic with whom? Neon. That's good. Drive toward stability. Okay, now, chlorine. What's it going to want to do? Gain or lose? Gain. How many? 1. If it gains 1, what charge does it take on? -1. Well, guess what? This whole family, each one of them want to gain 1. Each one of them will become -1 is the most likely charge it's going to take on. Because to be like a noble gas confers a lot of stability. And when I say be like a noble gas, I mean the same number of electrons. They don't change the nucleus. Remember, we as ordinary chemists don't screw around with the nucleus? Okay, so you got power now. -1 is the most likely charge. -2, the most likely charge. Minus how many? 3. Okay, that's no man's land. Because it'd have to gain 4, and evidently that costs you too much to do. Okay? All right, now, it's going to get just a little bit harder. Okay, let's say I have a sodium. Sodium has a choice. It wants to become more stable. Okay, it could gain 7 and go all the way out to be like argon. Or, what else could it do? Lose 1. Because if it loses 1, it becomes isoelectronic with what? Neon. So, it's going to lose 1. It's going to do whichever's the easier. Okay, so, if it loses 1, what charge does it take on, Eddie? +1, exactly. Take a wild guess. You've never heard of cesium before in your life. What's its most common charge? +1. Family members are related. If I had your brother or sister and they got an A, that probably means they're smart, you're smart too. Okay? So, +1, +1, +1, +1, when they become charged. Okay? Now, I have some calcium. What's the calcium going to do? Gain or lose? Lose 2. And if it loses 2, what charge does it take on? +2. Okay, so in chapter 1, where I chose fluoride -1 and I chose sodium +1, I didn't just pull those out of my ear. Okay, that's what they become, because there's a drive towards stability. Okay, now let's go over here. I have some aluminum. Okay. We usually work with the A families. They're called representative elements because they're predictable in how many they're going to gain or lose. These guys in the middle, the B families, they're not as predictable. We don't use them as much in examples. So, you've got those now. Let's come to aluminum. And you're going to think of what's the easier thing to do? The gain, the lose, what's it probably going to do? Pedro, tell me what an aluminum's going to do. Lose how many? 1? 3. Up your bit. It's going to lose 3. Because if it loses 3, it becomes isoelectronic with what?
Neon.
Neon. And if it loses 3, what charge does it take on? +3. Excellent. Excellent. Okay. All right. Okay, ask.
Iron.
Okay, see, it's a B family. It's a rogue state. It can be +2 or +3.
Okay.
Life is complex.
Okay.
Okay, and you can't do, yeah, the stuff here in the B, Bruce is asking about this because he just can't wait. But they're not as predictable. They have variable charges depending upon experimental conditions. So, we're going to work with these A families right now. Okay, Tran, point at something that's going to be -3, and you can't take the same one we did before. I want something that's going to take on a -3 charge, probably. Okay, AS, what is it? You're going to poison your husband. Arsenic. You got to know that so you know what to buy.